Hello everyone, I'm Wallapa Patharaputikun.
And I'm Siriya Maitripong.
We are students from Thailand. Thailand is the world's major rubber producer. We are sending tons and tons of rubber all over the world. Thai rubber plantation farmers still prefer to convert fresh latex to raw rubber sheets because the price of rubber sheets is higher than rubber latex. Processing of raw rubber latex into rubber sheets can be done in two ways: by fumigating raw rubber sheets or by drying raw rubber sheets using sunlight. However, the fumigation process costs very high and often face issues, such as heat loss. Although drying by sunlight is cheap and non-toxic, this method forces rubber sheets be exposed by UV ray, resulting in dark and sticky rubber sheets, which mean the price is falling. So, we did a lot of research and found nanoparticles called nitrogen doped graphene quantum dots. This amazing particle absorb UV light and emit light in longer wavelength. For example, near infrared ray. This means if we make the roof out of the particle, this roof not only protects the rubber sheets from UV rays, but also produced infrared ray. In other words, heat waves. This allows farmers to reduce their energy costs. Consequently, nitrogen-doped graphene quantum dots roof will be able to increase the country's potential in rubber sheet export, as well as the income of rubber farmers. This makes it possible to upgrade the country economy in dimensions of rubber, which is an important export product of Thailand. Therefore, it is considered to upgrade the economy of Thailand as well. This leads us to four questions. First, to what extent do different durations for the synthesis of nitrogen-doped graphene quantum dots by hydrothermal method affects the wavelength absorbed and emitted by the nitrogen-doped graphene quantum dots? Second, to what extent do different durations for the synthesis of nitrogen-doped graphene quantum dots by solar thermal method affects the wavelength absorbed and emitted by the nitrogen-doped graphene quantum dots? Third, to what extent does the roof from nitrogen-doped graphene quantum dots meet the ASTM D882 standard physical properties? Fourth, to what extent does the roof from nitrogen-doped graphene quantum dots effective in retaining heat in the drying chamber?
For the experiment methodology, first objective is study of the wavelength absorbed and emitted by nitrogen-doped graphene quantum dots when using different hydrothermal synthesis periods. We started by synthesizing nitrogen-doped graphene quantum dot particles using citric acid and urea. Both chemicals were added to the deionized water, and it was stirred until the solution was fully dissolved. Then, add the prepared solution into a Teflon-lined autoclave and heat. When the synthesis process finished, bring out the solution and use a UV-vis spectrophotometer to observe the wavelength absorbed by T2 and T4. Next, observe emitted spectrum by fluorescent spectrophotometer using different excitation wavelengths, followed by the second objective, study of the wavelengths absorbed and emitted by nitrogen-doped graphene quantum dots when using different solar thermal synthesis periods. These experiments is similar to the previous one, except that we changed the solution from deionized water to sulfuric acid. Next, the third objective is studying the physical properties of nitrogen-doped graphene quantum dot roof with ASTM D882 standard. We choose conditions from first and second experiments, which can absorb light at the widest spectrum and have the highest fluorescent intensity, and can emit the highest wavelength and have the most fluorescent intensity, respectively. Then, we mix the particle solution with PVA, followed by heat the solution and slowly stir. When done, put the solution into the mold. The physical properties can be tested by cutting the sample into small pieces and measuring the stress and strain by tensile tester. Finally, The last objective is studying of the heat storage efficiency of rubber drying chamber from nitrogen doped graphene quantum dot proof. We built the drying chamber using two layers. First, PUV at the top part, and second, PIR at the bottom. After that, bring the chamber outdoors and measure the temperature inside and outside the chamber 3 times a day for 7 days. After working hard for months, we got interesting and satisfying results. Starting off with a study of the wavelengths absorbed and emitted by nitrogen doped graphene quantum dots when using different hydrothermal synthesis periods. Graph 1 shows that T2 and T4 absorb light in the UV range. The graph also shows that T4 had a wider absorbance range and both had the greatest absorbance in the UV range. This is because of the band gap size, or the energy band, of nitrogen doped graphene quantum dots is approximately 4 electron volt, and the particles do not absorb light with a lower energy than the energy band. The energy of UV light is 3 to 124 electron volt, allowing the nitrogen doped graphene quantum dots particles to absorb light in the UV range. When comparing these two graphs, T4 had higher fluorescence intensity than T2. The synthesis time of nitrogen doped graphene quantum dots affects the particle size. If the particles are too large, the optical properties of nitrogen doped graphene quantum dots are also reduced. From the experimental results, it was seen that the 2-hour synthesis time had lower fluorescent intensity values than the 4-hour synthesis time. This was followed by the study of the wavelengths absorbed and emitted by nitrogen doped graphene quantum dots when using different servothermal synthesis periods. Graph 3 shows that all conditions had the greatest absorbance in the UV range. When comparing these three graphs, TS6 had the greatest fluorescent intensity. Servothermal synthesis used sulfuric acid as a solvent, which gives a sulfur coating to the nitrogen doped graphene quantum dots particle. This reduced the energy band size, which made TS4, TS6, and TS8 absorb and emit light at higher wavelength than T4 and T6 stars. This phenomenon is called redshift.
Next is studying the physical properties of nitrogen doped graphene quantum dots group with ASTM B882 standard. As shown in graph 7, PIR had the lowest stress and elongation at break, while PVA had the highest. PUV can be stretched the most at 141%, and the least is PIR at 124%. The tensile strength of PIR, PVA, and PUV were 40, 71.5, and 61 respectively. Since PIR roofing sheets contain acids, in 2000, it was reported that acetic acid content affects the structure of the PVA sheet, resulting in a decrease in the thickness of the PVA sheet and an increase in porosity due to the hydrogen ion concentration. Similarly, PUV still showed a stress strain curve comparable to PVA, but slightly lower because of the mixture of the particle. Lastly, study of the heat storage efficiency of rubber drying chamber from nitrogen doped graphene quantum dots roof. The results shown that average temperature inside the chamber is higher than outside at roughly 43 degrees Celsius, which is the appropriate temperature for drying rubber sheets. Gathering all the results we found, we can conclude that the rubber drying chamber from nitrogen doped graphene quantum dots can protect rubber from UV rays because PUV can absorb it, and the roof can produce heat as it can be seen from the last experiment. Moreover, the physical properties are satisfactory enough for our future research. We assure that our project had a long way to go, and we are confident in our ability to continue researching and learning more about this project. We plan to adapt our innovation to urban society to promote UV protection of people's skin or eyes. For example, it could be adapted to glass surface like windows and film covers, such as on mobile phone. In addition, it could be adapted to greenhouse to help make the crops like spectrum more specific, which would have a positive effects on the growth of vegetable.
According to the research, 0.64 ton carbon dioxide equivalent was produced by the 1 ton of transformation rubber fumigation sheet. However, if the farmer and the government use our innovation, the number of carbon dioxide emission will be reduced. And when our innovations are used for 10 years, only in Thailand, that equals the entire UK stop drying for 2 years. If the whole rubber farmer in the world choose our innovations, imagine how much carbon dioxide we can reduce.
Thank you for your attention.